Good evening, my young friends. In the space science, in our previous class, we have stopped with the establishment details of ISRO, Indian Satellite Research and Space Research Organization, ISRO. We also touched the commercial wings of the ministry. There we have stopped. Today, we will try to cover the space launch centers and space research in private segment, then orbits and space launch vehicles. Maybe it is ambitious that I am planning to cover all these four aspects today, but covering the topics is not my priority. Covering the information at a comfortable level so that you will be able to understand, that is my priority. I may go slow, but I will try to cover majority of the aspects. Pace is not important here, but try to understand now what all the information that's being provided. Many unknown terms will come during this lecture, but however, you will try to put up with that to an extent that if such kind of a word appears somewhere, you should be able to recollect that what we have now discussed here in the class. Straight away, I am going to space launch centers. We have in India, we have selected two centers to launch any satellite into the orbit. Those are called satellite launch vehicles. But to launch a satellite, the spaceship is called a satellite launch vehicle. And where from you will send these satellite launch vehicles and satellites into the orbit. All places are suitable for this purpose, or you have any set criteria. This is more important. Why India, such a bigger nation, only two centers are identified. One is Sriharikota, second is Tumba Equatorial Rocket Launching Center, Trivandrum. If I say about Thiruvananthapuram or Trivandrum, you should immediately, it should strike into your mind that we talked about Vikram Sarabhai Space Center there in Trivandrum under ISRO, ISRO. So what for Vikram Sarabhai Space Center, what is the main function of the center? If you remember, that basically concentrates on designing the space launch vehicles. Well, here people consider many factors to identify a center as a space launch center. In all over India, this is the criteria. This criteria is being followed. That is why you have very few centers all over the world. I'm talking about the 5 important points which you need to keep in mind whenever the space launch center, whenever that's being discussed. Well, first thing is, it should be near to the equator. That is the first point. Equatorial line, almost near to the equatorial line, if a center is placed, if the center is there, that is the most ideal spot to identify the center as a space launch center. Why equatorial line is preferred? Here, while the Earth is revolving around in its orbit, if it's revolving around the sun, at equators, the speed, the velocity of the Earth is very fast compared to the poles. When it's going to the polar area, the speed is very slow. It moves very slow manner. But at the equatorial region, on the equator, it moves really faster, at least 1400 kilometers to 1500 kilometers per hour. So when you launch a vehicle in the equatorial plane, the velocity, the launch vehicle gets an additional velocity of this 1400 per additionally, in addition to what is planned for the launch vehicle. This is without adding a single drop of fuel, without spending a single pi. The launch vehicle gets a boost of 1400 kilometers per hour. That is the major thing now. If a vehicle is launched from the equatorial area, that is the first thing. Addition of adding a velocity at a adding a free velocity of 1400 kilometers per hour, and you are saving on the fuel. Even the thrust also, main thrust, that means no, first time you are sending the vehicle into the orbit, that time the amount of fuel you used when you are sending a spacecraft from that center compared to other centers, here the amount of fuel which is required to give that thrust will be less. These are the two additional features. And the third one inbuilt factor when you are launching from the equatorial equatorial area, is that sending any satellite into a geostationary or geotransfer orbits is very much easier and lesser number of failures occur. These 3 points you need to keep in mind whenever now somebody is talking about a space launch center. They may give 2 reasons, they may not give the third reason. Third reason would also be there. Why you need to identify all the reasons is that in a question, 3 reasons, 2 reasons will be touched. The third reason in an obliterated way if they give, but you should be able to identify that's the correct answer or that is the false answer. So there you get a confusion. That's why you need to keep all 3 reasons. Another, I told you the sub reasons when you are launching from equatorial line. The second important thing is it should be located near the coast, that too east coast. If it is near to the coast, what is the advantage? All launch efforts will not culminate in success. Some may fail. When a launch vehicle is, when a satellite is being sent into the space, and no, it doesn't go in the planned direction, something went wrong sometime, it falls onto the earth again. That means no, where it should fall? Should it fall on the area where is inhabited, on the houses of the people, or in agriculture areas? Everything, no, that kind of a thing creates a lot of damage. Why I am saying east coast is that eastwardly you are now sending a vehicle, that is the first thing. Coast means if at all our launch effort is a failure, the vehicle again drops in the ocean without causing any damage to the people or mankind or habitat. That is the one of the important things now they keep in their mind. All centers, prominent space launch centers, are all on coast. Majority are in the east coast, some in the coast also. Selecting a coast is though the point lying behind selecting an area and coast. This is the point. The third point, it should be nearer to road rail link. Road rail link nearer to the transportation facility is very important because all parts will not be, they will be manufactured at various centers of ISRO. They have to come to one place, this launch center. There they get assembled and then that will be launched. Then larger vehicles with no 24 tires and then no 36 tires, such kind of a vehicles will bring all these components to launch station. For that, your road should be strong. You should be approachable. And some of the components will come by train also. There also, it should be nearer to be transported to the launch site so that it can be used perfectly. That's why road rail ring is important. That also they see. The fourth one, suitability of the weather. Preferably, it should be a low rainfall area and seasonally, and that should you should be able to know judge seasonably during what season this rains occurs and how much will be the average rainfall, all those things. And the weather conditions would not be greatly different during the seasons. Most of the time, it should be a congenial atmosphere for launch of a vehicle. That means, no, the sky should be clear. There should not be any untoward developments in the sky, so that the launch gets either postponed or gets delayed or it gets cancelled. That's why weather conditions should be really congenial for vehicle. That's the fourth point I said. The fifth point is when the vehicle is going into the sky, when it is thrown into the sky with the help of boosters, rockets, and then no engines, lot of fuel, what happens is that the launch itself no is a very huge. The rocket which they are using is roughly 20 meters plus height. Weight will be in hundreds of tons. It's a bigger one, no, it will be hundreds of tons. But if it is a smaller one, even then, with that this boost and go while going, what happens is that there will be seismic vibrations. There will be tremors on the earth. In the earth, there will be vibrations in the earth. The vibrations should not cause any. The soil should not get no. The furrow should not happen in the soil. The soil at that side should be really strong. That means no. Ideally, a rocky one. A rocky soil makes you stand any kind of a pressure. When the rocket is going into the sky, whatever tremors it is causing, the soil will be able to withstand, provided it's strong. These are the five reasons, five conditions they see while selecting a site for space launch. So, I will repeat these five. It should be near the equatorial region because it gets no added velocity. Second is it should be in the preferably east coastal area. Third, approachable to rail and road links. Fourth is weather conditions should be most of the time no congenial for rocket launch. Low rainfall. Fifth point is the soil should be really strong, ideally rocky. So these are the five features that decide selection of a spot, selection of a center for rocket launch. In India, you have one in Sriharikota, that's in Nellore Jilla of Andhra Pradesh. Second is Tumba, Trivandrum. The Tumba center is called, Sriharikota is called SHAR, HHAR. Tumba center is called TERLS, Tumba Equatorial Rocket Launching Station. That is in Trivandrum. From Trivandrum, only rockets used to get launched. Now, earlier reasons before SHAR is developed, all rockets in the preliminary stages, Tumba was the center, but some of the rockets we used to send to, because we don't have a perfect launching center, we used to send to Soviet Union and French Guyana, sometimes to NASA also for launching our satellites. Now we have a full-fledged center, SHAR. This is serving the international. This started international support also. That means now many countries are depending on SHAR for sending their satellites through our launch vehicles. So that's why it is getting commercially also viable. I tell you only a simple fact. This is only a matter of interest. When you are taking any satellite from some country, in order to get it launched as per their desired orbit, you will charge somewhere around the world other centers used to charge at least $40,000 per kg of payload. That means a satellite is weighing about 1,000 kg. It is per kg almost 30 lakhs rupees you are charging. If it is 1,000 kg, almost 300 crores, no, they need to pay to us to send this satellite, their satellite, into the orbit. That means the cost of the launch vehicle itself is somewhere around 360 to 400 crores. You are recovering the cost of cost of it. That's why it is now being tried for commercial uses also. Some of the rocket launch centers worldwide, important one, I'm only reading out so that now you will remember the name, that's all. Whenever it appears in the newspapers, you will have to diligently follow the newspapers development in space science. Whatever small development is happening, that you need to keep it to your mind so that the questions are generally formed not from the static content. Very rarely they give a question from the static content. They always link up the static content to the current development. That's why you need to be really careful while reading a newspaper. Don't leave any development that is occurring in a space segment. Some of the centers I am only reading out for academic interest. You need not know, remember all of them. Sriharikota, I told you, they have no two launch pads. That means no two rockets. You have like two platforms, two launch pads they have. In Japan, their center is called major center is Tangeshima is their center. Xichang is China. Kourou, you need to remember, France. This is the world. This is the foremost center. We were also depending on Kourou, French Guiana. This center we have also sent many satellites. Now worldwide, many countries prefer Kourou. There, the success of the launch was no really astounding. It is 95% success is there from Kourou. So this is one center you generally see. Here they have 4 launch pads. Then NASA, there are 3 centers. Vandenberg in California is one center. Kennedy Space Center from Florida is another center. Cape Canaveral is another center that is also in Florida. These 3 come under NASA. Then Ezin, EJIN is a China center, Chinese center. But no, they are not taking any other countries flat. They are developed their own. No, they are using their facility for their own purposes. Then another thing which you need to remember, this is the oldest center, Baikonur Cosmodrome in East Russia, now in Kyrgyzstan. It has launched more than 1,000 missions. It has got 5 launch pads. Earlier they used to have 70 launch pads. Now slowly everything is reduced. Now it has come to 5. With this we have covered space launch centers and the characteristics, and then now worldwide some names. Now if we move to private agencies in space segment. Space nowadays has become really important in telecommunications, in weather conditions, remote sensing, and then now exploration of various things like minerals, all these things. Space research has become really contributory. These things in detail we will talk when we are discussing about application of space science. Now, you may ask me, only governments are taking care of this space research, or any private agency is also active in space research? Are they also sending their rockets into the space? They are also contributing. You may ask that. Yes, 1984, Reagan government has given an opening to private agents. They have thrown the space research into private segment also. Anybody who wants to develop research in space technology, like developing a launch vehicle, developing a satellite, developing any kind of a thing which is now commercially viable, which needs to be sent to the orbit, they have given permission to the private agencies also. From 84 onwards, many private agencies are doing work here. Almost 70 private agencies are there all over the world who are actively involved in space research. Out of that, we only discuss about 3 4 very prominent and front runners in private space research. First is SpaceX. SpaceX is the one which has come really last 4 years or 5 years has come into real prominence. The SpaceX, their motto is interplanetary movement of the mankind is their motto. That means they are developing a technology to take the, like you are taking you are like you are seeing an airplane, like that they want to take loads of people onto the next planet. It can be Mars, it can be moon, it can be any planet. For that they are developing both the things, a launch vehicle they are developing and a capsule also they are developing. Manned missions, now when we talk about no Chandrayaan, Mangalayaan, and then no where astronauts went into the moon on various missions, when we are talking about it we can think of these modules, the the uh, capsule, all those things, no, we discuss about that. But here you need to remember SpaceX is the one which is active in space research. They are, they have recently tested a launch module also. Now NASA, part of the research activities, part of the design activities, part of the developmental activities, launch activities also, NASA has started giving contracts to private agencies. That is why private agencies in space are doing billions of rupees worth commercial activity. You remember SpaceX? This is started by one entrepreneur called Elon Musk. Elon Musk. His name, whenever you find in any kind of a article, Elon Musk, he is the pioneer of SpaceX, which is a private space agency. The second one of equal importance is Virgin Galactic. Virgin Galactic, GALACTIC. Virgin Galactic is the one which is actively into the private space flight. They want to take the celebrities into the space and then give them an experience of space walking, moonwalking, spacewalking, such kind of an experiences they want to give it to the wealthy individuals. Of course, the cost will be really high, yet one who has money, who wants to have similar kind of experience, who want to remain a very few individuals, who had got that experience all over the world. Now, for such kind of an operations, this Virgin Galactic is planning. It is also actively contributing in research to reduce the cost of the launch vehicle, reusable launch vehicle. That means one time it's going and coming, but it has to come back, and then again you should be able to send the same vehicle again into the space on some other mission. Likewise, many times they want to use it like a flight or a bus. That is the another one. The third is a Blue Origin. Blue Origin, it is passenger escape systems and unmanned missions. NASA has given contract to this. It is actually working in that space. The fourth one is Bigelow, Bigelow. It is a spacecraft launch design. It is working on a spacecraft launch design. That means reducing the weight of the spacecraft so that with the amount of fuel you are using, you can send the spacecraft into more longer distances. That it's working. What I meant is other things are, there is Oriental Science, Mircorp, Mircorp, MIRCORP is a Russian private agency. Space Adventurers is another agency. Orbital Science is another agency. Sierra Nevada Corporation is another agency. Out of that, the front runners currently in private space research is SpaceX, Virgin Galactic, Blue Origin, and Bigelow. Remember these four. You will get news about this now and then. Recently, if you remember, if you send the last 1 week's papers, if anybody has gone thoroughly, Virgin Galactic has tested levitating trains, sending passengers in a capsule. Levitating trains is a magnetic trains. You don't have any power and all that. Only with the difference in magnetic forces, the train moves. It is same principle. What you are seeing, what you are seeing in Russia and other countries, levitating trains are already there. They go with a speed of even up to 1,000 kilometers also. No noise is there, no pollution, and then no, it easily moves from one place. They successfully conducted an experiment wherein two of their employees were sent in a capsule. They have conducted an experiment for a distance of 150 meters, wherein they have successfully completed the mission in 15 seconds. Their objective is from one part to the other in the world. No journey should take more than an hour. That is their objective. They are working on trains, this transportation segment also, besides space research. Now, these private space research centers, are they limited to other countries? Do we have anything in India? Yes. In India also, we have some names coming up. They are actively coordinating with ISRO. ISRO also giving technology to them, encouraging in research. Slowly they are giving contracts for certain of the aspects in the whole process. They are getting some contracts. On their own, they are also trying to develop space launch vehicles, rockets. Research is going on. Majority of them are started by the scientists, retired scientists, or scientists who resigned from ISRO. They worked on satellite launch vehicles, they worked in satellites, and then they came out, they started these centers, and they are attracting public funds. Some of the names you need to remember in India is Skyroot. Skyroot. It is based in Hyderabad. They have developed an engine called Vikram. Vikram is nothing but they have developed this is a rocket called Vikram. Vikram is nothing but Vikram Sarabhai. This is a commemoration of Vikram Sarabhai. This is Vikram.